Hi, welcome to C Sharp Essentials. We have put this course together to try and help people who would like to learn to program and to program with the C Sharp programming language to get to a position where they have the confidence in their abilities as a C Sharp programmer to continue at their own pace. Please understand that this is a journey. It's not a one-stop destination. You need to be prepared to join us in investing your passion and your time in this process. Please also understand that this is not a spectator sport. You're going to need to get your hands dirty. You can't simply sit and watch videos and expect to learn how to be an experienced programmer. You need to please try and follow the examples we're going to show you on the screen, try them on your own computer, and learn from your mistakes. In this first module of the series, we're not going to look at code. We're going to talk about key concepts, terminology, and how various terms and technologies plug in together to make our C# and .NET environment work. So we're going to start by learning what .NET is and how it fits into the great scheme of things, why we need .NET, why we can't just use C# on its own. And that's going to expose us to a whole bunch of important concepts and terms and various pros and cons of using C# and .NET in the real world. We're then going to focus very importantly on what you need to do to set up your computer so that you can follow along at home. And this is really important. As we emphasized before, this is not a spectator sport. You need to get your hands dirty. You need to try the examples that we will show you in future modules that will familiarize you with C# and help build your confidence. In order to get a better understanding of how .NET fits into our world as C# coders, as C# programmers, we need to have a little bit of better understanding of where .NET fits into the overall scheme of things. So on our computer, be it a hardware like a laptop or a desktop or a server, it doesn't matter. We're going to have all of these hardware devices, what we often call a hard layer in our stack. Conceptually, we call this a stack because these things are conceptually layered on top of each other. So we have our hardware. Very importantly for us as developers, we're typically concerned about the processor, the CPU, how it can perform, sometimes a GPU as well. We're very concerned about RAM, volatile memory, volatile meaning you turn off the power, the contents is gone. We also in a computer would have what is known as secondary storage or storage like hard disk drives, SSDs, and they are non-volatile. That's where stuff is permanently stored so that when you turn the computer off and turn it back on, the content is still there. But we are primarily, as programmers, we're going to create these programs or applications that create data of different types and manipulate them. And they will be stored in RAM. So processor and RAM are very important resources for us as developers. Then there's also network interfaces, things, how do I connect to a remote server on the web or whatever. We'll come back to that. On top of our hardware layer, we have our operating system. Historically, the only operating system that supported .NET was Microsoft Windows. But more recently, this has been extended so that modern .NET runs on Windows and Linux and Mac OS operating systems. We'll come back to that in a bit. Now our operating system, and this is a huge simplification, but please bear with me, our operating system essentially consists of a bunch of device drivers, sometimes referred to as the hardware abstraction layer, and they are bits of code, specially written typically in C or C++, and what they do is they tell the operating system code how to talk to the specific hardware in our computer. So the specific make and model of the processor and RAM and network card and stuff, because that could be different from one computer to another, or in fact even within one computer. So the device drivers live above the hardware and provide an interface between the hardware layer and the operating system. The operating system primarily consists of a kernel, the core, if you will, of the kernel, that is responsible for task scheduling and sharing resources, access to hardware resources amongst many applications, which we'll come back to, that sort of thing. Then the kernel also has a bunch of background services, and very often we refer to them as services or daemons or managers, doesn't matter. We've got a memory manager typically, which we'll come back to. We'll have some file system services managers, one or more of them, that manage how we create files and directories on our secondary storage devices. And then we'll have network drivers, network managers, network services that will provide the means by which we can support protocols like TCP/IP, or TCP and IP and UDP and HTTP and other network protocols. So on top of that, we as a programmer, we develop our legacy, let's put it over here, our legacy business application. And we've done this, say, 20 years ago. It was built to match or to satisfy the specific business requirements for our application. Maybe it's an order entry application or a payroll application, or it really doesn't matter. The point is it's not a standard application. It's something that we as developers, because that's the whole point of this course, we as developers, we built this application to do something specific for our business. And historically, 20 odd years ago, we would have typically, for Windows, because remember we are in this case running on Windows as an example, we would have typically written this application using a programming language called C++ or C. There are other options. C++ is typically ideal if you wanted high performance, high reliability applications to run very well in the Windows world. You'll find that many of the applications, for example, that you buy from Microsoft to run on Windows, like Microsoft Office, were typically developed in C++. However, there were other options. Visual Basic 6 was the highest version of Visual Basic that ran on Windows before .NET. And there were others, programming languages like Delphi. Doesn't really matter. Point is, you would have chosen a programming language, and as developers, we would have been responsible for satisfying the business requirements, i.e. writing the code that does whatever the order processing stuff needs or whatever, and we would also have had to written code to deal with everything we needed to use in the operating system level. Very notably, if we were C++ programmers, we would have had to have code in our application, in addition to the business rules code, additional code that was responsible for allocating memory because we wanted to store stuff in RAM. Volatile memory. We've got temporary variables in our applications and we need space to store them, and maybe they're going to grow as the application runs, so we need to manage this memory. So we would have had code in our application to deal with this requirement, and it's a lot of code. It's very complex. Some programming environments like VB6 simplified this for us, but very notably C++, this is something we would have had to do. And very significantly, after we'd finished using our data space in our application, if our application was running for a long time, and for short periods of time within that period, it had temporary data storage requirements, we would have to remember as developers to tell the operating system to free up the memory that we were previously using, because otherwise that memory is no longer available for any other applications that are running in our environment. Now, if we forget to do this, and this unfortunately happened a lot, if we forgot to free up that memory, then eventually we would get what we call memory leaks. Memory leak. i.e. it's like a bucket leaking water. Our application leaks memory from our operating system and just doesn't give it back. And the problem with memory leaks is over time, our applications will get slower and slower and slower. All other applications running on the machine would get slower as well, typically. And eventually, the operating system would completely, the reason it would get slower, by the way, is the operating system memory manager would implement a thing called virtual memory. I'll just write that here, virtual memory. And what that does is it uses hard disk to compensate for the fact that memory is typically not as large as secondary storages. So we get what this is called disk swapping or swap files. The problem is your memory performance gets slower and slower and slower as you get shorter and shorter and shorter of RAM, and eventually all other applications suffer from the same slower and slower memory pool. Eventually your operating system runs out of virtual memory and everything dies. So not only do you get performance deterioration with these memory management issues, but over time you also get reliability issues because you have programs that just, for no particularly good reason, just suddenly stop working. So let's compare and contrast that with the world of .NET. Around 25 years ago, Microsoft released .NET. You may get a bit confused about the name here. This is just .NET. We just call it .NET. But originally this was called the .NET Framework. And then that was only run on Windows. This was 25 roughly years ago in the early 2000s. When .NET was first released, it was called the .NET Framework. But it only ran on Windows. Then Microsoft opened it up to the open source community. .NET became open source, as did C#, and so then other versions of .NET were developed to run on Linux and macOS, and so it was then called .NET Core, and then eventually it was all just brought back together, and now we just refer to .NET. But .NET, if you're talking about .NET Framework now, you're talking about a very, very old version of .NET, significantly. We're going to talk about .NET, the new modern version of .NET. Now, the .NET platform, and you can consider this to be kind of an extension on the operating system. It's going to provide a place in which our .NET applications will run. And notably, these .NET applications can be developed on programming languages like C# or VB.NET, Visual Basic.NET. It's a very different Visual Basic from Visual Basic 6. These programming languages, another one called F#. The point is that inside the .NET framework, there's a mechanism called the Common Language Runtime. Language Runtime. Or, quite simply, CLR. And the Common Language Runtime is the mechanism within .NET that allows these various different programming languages, like F# is another one, to be supported and to execute, provide a platform for the execution of programs written in C#, VB.NET and F#, all in one environment. So it extends the operating system upwards, if you will. It provides more application-related services, whereas in contrast, the operating system is more about sharing hardware resources for the application to use. Now, the .NET platform, .NET, includes other very important extensions here, very much like our operating system had file services and network services. So here we have memory services, memory manager. Sorry, I don't have enough space, but very notably the garbage collector, the GC. I'll write this somewhere else, garbage. Garbage collector and the memory manager is a very, very important aspect of our .NET environment as programmers. Another thing that we will have here potentially as an add-on if we need it optionally. Sorry, we will always, whatever application we develop for .NET, we'll always use Common Language Runtime and the Memory Manager. But there are other optional things that could be used. One of them, for example, is a thing called ActiveServerPages.net. And that's an add-on that helps us to build websites and web services in the .NET world. And there's another one, I'll just put it here. There's many of them. I'll just put ActiveXDataObjects.net, ADO. There's also Entity Framework. There's other things. We're not concerned about that. ASP.NET is there to help us build web applications. These can either be websites or web API services or both. ADO.NET is a mechanism that's added into the .NET environment that simplifies the amount of code or the code that we need to connect to external databases to retrieve data, update data, create data in the database environment. So our business app here, and this is really important, our business app, we migrate our legacy business requirements. Probably they've changed, but it doesn't matter. We replace our old legacy app with .NET. And there's a few reasons why we are doing this. One really important reason is that if certain kinds of applications, this app, once it's migrated, could run on operating systems other than Windows, because it's a .NET app, and .NET runs on Windows and Linux and Mac. So compatible applications, appropriately developed applications, would run on those operating systems as well. Very notably web API services. However, another thing that's really important is, as a developer building this application in C#, we don't need to go and negotiate with the operating system for memory. All we do here is we declare our data space, our data variable requirements. We just declare them in our C# code, and the memory manager, when our application is running, the memory manager is kind of sitting in the background watching our application run. And this is a trivialization, but the memory manager is watching us, and it sees what variables we need in our C# apps, and we're going to be doing this. And the memory manager and the common language runtime will work together, and they'll figure out how to go and negotiate allocation of the memory for us on our behalf. And so we don't need code in our application to go and allocate the memory. But very, very significantly, when our application is finished with our variables, the variables we've created, the garbage collector can detect that. It can detect that memory space is no longer being used in our app and can automatically free it up, so that memory then becomes available for other users without us encountering memory leaks and without us having to write complex code that has to remember to go and free up our memory afterwards. So our garbage collector is kind of walking behind us as programmers, if you will, conceptually walking behind us as our program runs, clearing up our mess as we go along, so that we don't have to write code to manage that complexity. So there you have it. Some very, very important reasons why we use .NET is that we've got memory management, we've got the portability, and there's another one. If we were building our legacy app, let's say in C++ or VB or whatever, and we had an external database out there, maybe a Microsoft SQL Server, MS SQL, and maybe also, another one, an Oracle database, and we wanted to work with both of these databases, then we would have to have different chunks of code in our application to work with these different database products separately, because they work in slightly different ways. They ultimately do the same thing, but the code is different. So you would have to have built those different chunks of code into your application, into your code base. In .NET, ADO.NET does that for us. So we just use one set of code, and ADO.NET deals with the transparency between different external database providers, and that's really important. We do this a lot. We also do this as developers when we're building websites, for example. We have to, historically, if we were building a legacy website here, we'd have to put in a lot of code to deal with how to build an API or API listener or whatever. We call this kind of code plumbing. because it's the kind of code that you assume is there underneath. It works, it does stuff for you. It's not related to your business requirements. It's the stuff that's needed underneath. Manage memory, connect to databases, deal with the web, deal with the network. That kind of plumbing code adds a lot of code to our code base for our legacy application that we then have to maintain. In the .NET world, that plumbing code is provided typically by standard ADO components within .NET, like ASP.NET and ADO.NET and the memory manager. So we don't have that plumbing code anymore. So our code for our application becomes much, much smaller. It becomes much more focused only on the actual business requirements and not on all of the plumbing as well. And that means that our application code is smaller and easier to maintain over time. Okay, so in summary, why do we need .NET? Well, it provides a platform that C# runs on because of the Common Language Runtime. And that platform works on multiple operating systems, Windows, Linux, and Mac OS. So you can develop a program, an application using C#, for example, very common example, a web API service that you could take the code and run it on Linux and Windows and Mac OS instead of just one operating system. Very important. Another thing is the managed memory and the garbage collector. Memory management code in legacy C++ and other similar programming languages is a huge cause of bugs and memory leaks and unreliable environments, and the garbage collector and memory manager just deals with a whole bunch of those issues for us. We also discussed the fact that we need less plumbing code, so we can easily use packages like ADO.NET or assemblies like ADO.NET and ASP.NET so that we get pre-built packaged plumbing code in the .NET environment so that we don't have to write lots and lots of code in our application to connect to the outside world and deal with infrastructure concerns. So an astute observer could say, well, why don't we just use Python instead? Because Python shares a lot of these characteristics. Surely if I wrote a Python app, it would run on Linux or Mac OS or Windows. Yes, that's absolutely true. And as a Python programmer, you don't need to allocate and free up memory. You don't need to worry about it. The Python runtime will manage memory for you. So that's also a shared characteristic. And also there are lots and lots of Python libraries out there to provide you with plumbing code similar to ASP.NET, for example, to build websites and web APIs and things like that. Those are all true. Those are shared characteristics of both Python and the C#.NET world. However, the differences are critically at the bottom. First of all, C# is a compiled programming language. That means as if you have syntactical errors that are in your code, they will be isolated and highlighted and will have to be eliminated before your code starts running. In a scripted interpretive language like Python, it is possible that code bugs could sneak through into your runtime environment and then only occur and destabilize your application when the code actually runs in infrequently accessed areas of your code. More about that later in the course. Another thing that's really important is the performance characteristics are radically different. Because C# is compiled and because the C# compiler is extremely efficient, runtime performance of C# is typically at least one order of magnitude, sometimes many times faster or more than an equivalent Python application. And I will demonstrate this for you later in the course, where we will compare a prime number filter written in Python to one written in C#, and you will see that for many types of code there is a radical difference in runtime performance that Python can't even attempt to approach in the real world. Okay, so briefly to end this session, what do we need? What do we need to set up in order to be able to practice the code sessions that you're going to see in this series. First of all, you need some kind of PC, some kind of computer to run on. This needs to be a computer running that's going to run Windows or Linux or Mac OS. It can't be a tablet. It can't be an Apple iPad or an Android tablet. It needs to be a computer. This is a great use, and you don't need lots of RAM and very high-end processor. The kinds of stuff that we're going to be doing hands-on in this course is very rudimentary. You don't need high-end kit. So it's a great way for you to make use of maybe an old laptop or an old desktop. Obviously, we need to have an operating system, one of the 3 supported for .NET, as shown here, installed on this hardware. I'm using Ubuntu Linux for all of the demonstrations in this course. The hardware that I'm using, if you're interested, is a reasonably old, I guess an 8-year-old Dell Precision laptop. It's got an Intel 7 processor and I think 16 gig of RAM in it, but there's certainly nothing fancy in today's standards. In July of 2026, it's considered to be an old refurbished laptop. To download .NET, it's really simple. Just go into your browser, search for .NET. You should find it pretty much at the top. This is what we're looking for. Download .NET for Linux, Mac OS, Windows. Fairly straightforward. I'm not going to do this in front of you. It's kind of silly. There's more than enough instruction and content available for you to figure this out. Essentially, the default that you will see is the one you want is .NET 10 SDK, Software Development Kit. And because I'm running on Linux, it's obviously showing me the Linux option. I just want to click on here to show you some other options that you do not need right now, but you may be interested in. You can also, if you don't download the SDK, you could download the ASP.NET Core runtime or the desktop runtime. These are what they say. Basically, if you develop an ASP.NET Web API application, for example, on your Windows machine and you want to install it to run on a Linux machine, then you only need to download the ASP.NET runtime for your Linux machine and then run your application on there. You don't need the SDK on both machines. Okay, so all we need to do now is go into our browser. In our browser, we just need to type in VS Code for Visual Studio Code, hit enter. There you go. You should go straight to get a link to download and install VS Code for your operating system. Obviously for me it's showing a Linux download because I'm running on Ubuntu. Turns out you can also use apt and similar commands on Ubuntu if you wish to install, or you can download the VS Code editor and then install it manually. There's lots and lots of instructions, so again I'm not going to repeat all of this for you. You will see that once you have VS Code installed on your machine, there is also an extension that we will use to enhance its knowledge and capabilities with respect to the C# programming language, but we're going to do that later. Thank you for spending this time with us. Your journey into C# has begun. Our future sessions, please rejoin us, subscribe, and then you'll get notifications as we add more sessions to this series. We will become more and more code focused, so in future sessions there are almost no diagrams and concepts and very much a focus on code using VS Code. Please like and subscribe if you will, because possibly you can help other aspirant C# hackers get access to our content in the future. And then we'd also really love your comment. Please let us know where you think we're going wrong, where you think we can do better, so that we can improve this content in the future. Thank you.